Welcome to Investigation 3.1, Flipping on a Grid. This is essentially coordinate rules for reflections. Our focus question for this is, how can you describe how points move under a reflection with coordinate rules in the form of x comma y becomes whatever, when the reflection line is across the x-axis, the y-axis, or the y is equal to x. So essentially we are going to be filling in these blanks with maybe saying, well, we times our x-axis by a -1 and our y stays the same, or something like that. But essentially we are going to be creating rules for what the y values or what the x values would potentially look like in any situation given a reflection across a certain line on a coordinate grid. So we're going to be looking specifically at points. So in our book, we are looking at this particular flag. So we have this flag and it has a few points, A, B, C, D, E. And very first question this book asks us is, what are the key coordinates for recreating this drawing? So if we were forced to recreate this drawing, what points would we have to pay attention to? And in that sort of thing, I always like to think about what are the landmark objects for this point. It would make sense that we pay attention to these coordinates pairs, essentially the ones for A, B, C, D, and E. So best thing to do is actually write them down and actually keep track of them. So A, its coordinate pair is 0, 0. B, we have 2, 4. Remember that X always comes before Y. C, we're going over to 5 and going up 4, so we have 5, 4 for that coordinate pair. D is 6, 6. And our last one, E, it looks like it's 3, 6. So those are our key sort of landmarks. Those are our key coordinates for recreating this drawing. We're going to have to pay attention to those as we do this. So we're going to go through A together, and then after that I'm going to give you another hypothetical situation that's not referred to in this book, and it's actually the situation of y is equal to -x, what would happen in that situation. So we're going to look at both of these. So let's start out with, let's copy and complete this table showing the coordinates of A through E and their images under a reflection on the y-axis. So we have A is 0, 0, B is 2, 4. We already know C, D, and E, so I'm just going to magically fill those in with the math magic. Hold on one moment. So a little shift. We've added in C, D, and E in those coordinates, and now it says that we need to reflect this drawing, this flag, over the y-axis. So let's look exactly at what that means. With our other drawings where we had things without a coordinate plane, we just had a line of reflection. In this case, though, we can look at an actual coordinate grid and find that line of reflection, and it says the y-axis is our line of reflection. So I insist that you draw that line of reflection into your actual drawing. So that's our line of reflection. That means that we are essentially taking any point on this side and transferring it so it's a mirror image on the other side. That seems easy enough, so let's do just that. Let's actually make that reflection. So our A point, it is actually on that, it stays in that exact same place. Our B point, it's going to be moving to 2 units over, but it's going to stay on that same y vertical, but it's just going to go to -2. If I look at our E point, it's going to go to the -3. Our D point is going to go to -6, 6, and C is going to be at -5, 4. So we can now recreate this drawing and connect our dots. So of course my drawing isn't perfect because I am drawing on an iPad. Let's see if I can fix this a little bit. There we go. And that one too. Perfect. And so if I wanted to now, and what I would insist that you do is you actually now label your points. We have A prime, we have B prime, D prime up here, E prime, and C prime. So those are our different points that we have. Let's go back and see what we need to do after that. looks like we need to add in our coordinates after the reflection. So we need to fill in this part of the table. So looking at this, we're going to start to fill in those points. B prime is no longer just, or B prime is not 2, 4, it's at negative 2, 4. So we're going to write that in. It's at negative 2, 4. C prime is at negative 5, 4. So we're going to add that in. It's at negative 5, 4. D prime was at negative 6, 6. And E prime, let's look at it again. E prime, whoops, I actually mislabeled D and E, so I actually should fix that. This one is D prime, and this one is E prime. Sorry about that. So E prime is at negative 3, 6. Negative 3, 6. And the one that's kind of interesting is A prime and A are still the exact same point. So it still remains to be at 0, 0. And that's because A is on the line of reflection. It's not going to move anywhere. It's going to stay there. So now we need to write a rule relating these coordinates of the key points and their images after the reflection in the y-axis. So after we reflected it across the y-axis, what is the rule that we can say for everything that happens with our x term and our y? So if I look at our y, it stays the same. It's always the same. It's just simply 4 remains 4 in the B and the C, and then D is also 6 in both of them. So it looks like y is unchanged. So we can just write down our rule as being y. Our x value, however, though, I notice that it is from a 5, it's turned into a negative 5. From the 6, it's become a negative 6. Our 3 has become a negative 3. So it looks like our x is not just x, it's a negative x. So our rule for this, I'm going to write it bigger so we can see it, is negative x, comma, y. That is our rule. I'm going to also increase my pen size so we have this. Negative x, comma, y is our rule. So the x values in that reflection become opposite of what they used to be. So then our next question, would your rule give the correct coordinates if the flag started in the second, third, or fourth quadrant? Justify your answer with sketches or samples of the coordinates that match. So if my flag was in this quadrant, maybe the third quadrant, if I had a flag over here, if I had a key point over here with maybe another key point, I'm going to maybe say it's in the shape of a backwards L. If I were to reflect it across the y-axis, I would see that all of these points still remain the same in our y. They still remain the same vertical. So the y is always going to be the same. But our x value is going to be opposite of that. So we have negative 3. If I were to reflect it across the y-axis, it becomes a positive 3. So that tells me that, yes, my rule is going to hold true. That's exactly what I need it to do, and that's exactly what this rule will always do. Do any of the points remain unchanged under this reflection? Explain. Well, yeah, point A remains unchanged because it is on the line of reflection, and that's important. Because it remains on the line of reflection, it is going to be unchanged. And do the flag and its image make a symmetric design? And yes, it does. They mirror each other. They have a line of reflection, so therefore they mirror each other. Let's go on to the next question that we have here. This one's a little bit more tricky. Our line of reflection this time is y is equal to negative x. Now you don't need to be able to do this exact situation. You need to be able to do a situation where y is equal to x. So your line is going to go in an opposite direction of this line. However, this is still important to pay attention to. Y is equal to negative x. The slope of this line is negative, but it essentially has a constant proportionality of 1 over 1. So the slope is just nice and steady in proportion as it goes down. So this line is our line of reflection. That means any point that is on the other side is going to have to be reflected across that line. So A, as we notice, it still stays right there on that line of reflection. It's not going to change. However, our B, that's going to change. Our E is going to change. Our C and our D are going to change. So let's see how they do that. If I look at our point B right here, it has a coordinate pair of 2, 4. So that means if I'm going to show this as a reflection, I need to pay attention to this slope it has right here going up 4 over 2. And this is going to be hard to fathom. We're actually going to be flipping that 90 degrees essentially, negative 4 down 2. So my new B point is going to be right over here. Your gut instinct is going to say that this drawing needs to look sort of almost like a rotation instead of a reflection, but unfortunately that gut instinct will not work in this case because we need to make sure that we're making a mirror image instead of just a reflection. So my new B point is actually negative 4, negative 2. Check that. All right, my next point, E, is going to be up 2 over 1 from that. So I'm going to go over 2 down 1. So there's my E point. My D point from there is straight across. So I'm going to go straight down. And my C point is essentially just a little up from that. So now I can draw my flag and connect the dots, and that is my reflected flag. If I were to write down the coordinates, we may or may not be able to make a great sort of description for this. We may not be able to make an easy rule for this, but perhaps we will. We're at negative 4, negative 5, and for this one we are at negative 6, negative 3. So prior to, we were at up here 5, 4, and we were at 6, 6, and here for E we were at 3, 6. So what I see actually happening with these points, I'm going to fill in this table over here. What I see happening with these points is it's not just changing my x to a negative or changing my y to a negative, but we are fully actually changing the coordinate pairs x and y. So my C, my D, and my E are drastically changing. D is 6, 6. I don't remember the other ones. 3, 6, I believe. And we have 5, 4. So our new coordinates are 0, 0. We also have negative 4, negative 2. We have negative 4, negative 5. We have negative 6, negative 6. That one's easy. And negative 6, negative 3. So our initial x, comma, y of our original figure is now becoming this crazy negative y, negative x. Essentially, every single time I had a point for x, it flipped to the y spot and became negative. Every single time I had a point for the y, it flipped to the x spot and became negative. So here is our rule to describe this reflection. We have x comma y becomes negative y, negative x. kind of interesting. So play around with this concept of reflection over a line. You'll do it for the x-axis, the y-axis, and the line y is equal to x. I'm going to show you exactly what that line looks like really quick because I can. It's going to be a line that goes like this. It'll be exactly the opposite of the one you've already done. So if you think about this, if we were to flip this image over this line, we're going to have our C point, instead of being right here, it's going to turn and become right there. Kind of interesting. So play around with this concept. Finish investigation 3.1 and try your hand at the homework. And if you have any questions, as always, make sure you ask in class or email me. Thank you so much. Bye.